Hi guys, we're back with lesson 4.2 and this is video 3 and we're still talking about rate of change, but this time we're going to talk about rate of change from an equation. So let's go ahead and get started here. We're looking at the first one here. We're talking about the slope of a linear function. For the slope of a linear function, we want to remember the slope-intercept form. This one is not in slope-intercept form. So if we take a few minutes and put this in slope-intercept form, if you will recall, then the m is my slope and the b is the y-intercept. So if I can just get this in slope-intercept form, I don't have to do any calculations because the rate of change is always the same on those. So remember, if it's in slope-intercept form, y has to be by itself. So we have to get rid of this 3x, and then we'll have to get rid of the 2. We get rid of the 3x first by subtracting 3x from both sides. And so we would be left with negative 2y is equal to 8 minus 3x. The negative 2 is still there, it's being multiplied, so we would divide by negative 2. We could do the whole side, but I much prefer to go ahead and break it apart and divide each part individually so that I can simplify. So when I look at this, negative 2 divided by negative 2 is 1, and that leaves me with my 1y. 8 divided by a negative 2 is a negative 4, and a negative divided by a negative is a positive 3/2 x. So my slope is my m value. That's the coefficient in front of x. So m is equal to 3/2, and that's the slope of that line. Because it's linear, I don't have to tell you over what interval. All you got to do is get it in slope-intercept form and find your x value. Now, when I go over here to this one, if you will recall, it has an exponent of 2, and exponents of 2 mean that it's a quadratic. It has this U shape right here. And since it has this U shape, it doesn't have a constant rate of change. So they have to tell me what interval to look at. So they told me from where x is equal to 1 to where x is equal to 2. We could have written it this way if we would have liked. It means the same thing as this. These two things are the same, okay? Those are the same. You're going to have to get really used to seeing it either way. So we know our x, we know our inputs, but we don't know our outputs. So we have to actually calculate those outputs. So let's just make us an input-output table. Here's my x's. The two x's that they told me were 1 and 2. So we're going to plug those values into my equation. So we're going to do 1 squared plus 2 times 1 minus 7. Now I'm going to caution you, remember if you are using your calculator, when you plug in values, you need to use your parentheses around them so that if you have a negative number and you're raising it to a power, your calculator actually calculates that correctly for you. So when you take this, you're going to get 1 plus 2 minus 7. So that's going to be 3 minus 7, which would be a negative 4. And over here, we're going to plug in a 2. 2 squared plus 2 times 2 minus 7. So we've got 4 plus 4 minus 7, or 8 minus 7, which would be 1. Now we know our x values, now we know our y values. So you subtract your y's, y2 minus y1 over x2 minus x1. Okay, so let me move this up here out of the way. Okay, so when we get to subtract those values, let's see what we will get. So we would have 1 minus a negative 4 over 2 minus 1. Change your signs right there. Okay, So you would have 1 minus a negative 4 over 2 minus 1. And when you calculate that, you would change your signs and you would get not 5 over 2, but you would get, oops, a pen. You'll get 5 over 1. So your rate of change would be 5. So you can look up here. How much did your y's change? 5 units. It went up 5 units. How much did your x's change? It went up 1 unit. So up 5 over 1. Okay. I think you have 2 for you guys to try now. So if you'll take a few minutes, pause and find your. So go ahead now and do the next 2 U-tries. Find your rate of change on each one of those and make sure you check your answers.